In the last part of the standard deviation lesson, we talked about this particular set of 15 data and how to use the graphing calculator to find the mean and the standard deviation using one variable statistics. Remember that standard deviation is the Greek letter sigma. There are two sigmas. Lowercase sigma is your standard deviation, whereas uppercase sigma, which looks like an E, that meant sum or add everything together. Now, the reason I go back to this is because we're going to talk about using standard deviation to describe data. The standard deviation means that all the data in this particular set are going to be some number of standard deviations away from the mean. So what I'm going to do is I'm going to make a little plot with x's, and you may have done something similar to this in middle school in terms of statistics. I'm going to make myself a little number line like I did when I made the box and whisker plot. And since my smallest number in the data here appears to be about 12, and my biggest number in the data is 24, I'm going to go from 10 to 30 on this little chart here, and maybe I'll go up by 2s. So 10, 12, oops, that's not looking good, 12, 14, 16, 18, 20, 22, 24, yeah, I'll go up to 26. We'll see how that works for us. The mean is at 17.6, so it's probably here somewhere. The standard deviations are going to be 3.5 units away from that line in either direction. So the first thing we'll talk about is one standard deviation away from the mean. To find one standard deviation away from the mean, we're going to start with the mean, and we're going to add the standard deviation. 17.6 plus 3.5 is 21.1, which would be about, I don't know, let's see, no, that's not a good place. Let's see if that's 20, that's 20. So maybe in here somewhere. We say that's one standard deviation away, but that's to the right of the mean. I can also find one standard deviation away going the other direction by subtracting the standard deviation from the mean, and 17.6 minus 3.5 is 14.1, which is probably around here somewhere. So this is one standard deviation away the other direction. Well, I don't have to go just one standard deviation away from the mean. I can go a second standard deviation away. So if I want to go 2 standard deviations away, then I'm going to subtract 3.5 twice, or add 3.5 twice. In other words, I'm going to do 17.6 plus 3.5 times 2, which is 7. And I'm going to get 24.6. So that's going to be about here. And then I'm going to do 17.6 minus 3.5 times 2, which is going to give me 10.6. It's just going to be over here somewhere. And that's a second standard deviation away from the mean. The next thing that we're going to do is we're going to make a little, there's a name for this and I can't remember what it is. I want to say it's like a frequency plot or something like that. Where I'm going to put X's where all the data are. So going back up here to my data, my first three are 19, 15, and 20. 19, 15, 20. 22, 21, 18. 22, 21, 18. 21, 13, 19. 21, 13, 19, 24, 17, let's see, 24, 17, 14, 12, and 15, 14. I want you to notice that all of these x's fall within 2 standard deviations of the mean. Often when we're describing data, we like to know how many standard deviations away from the mean our data fall. The less standard deviations, the more accurate the data. So with this, all the data falls within 2 standard deviations of the mean. That means that if I was making a prediction about the next value in this set, whatever this data represents, it would probably fall somewhere in this range, somewhere from 10.6 to 24.6. The nice thing about making this table is that it makes it easier to see the standard deviation intervals. And that's the end of standard deviation part 2.